Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're continuing our journey through the synchronization utilities season. We're in the advanced synchronization techniques chapter, and we'll be diving into the exchanger class. Victor, are you ready to exchange some knowledge with our listeners?
Absolutely, Sheila. I'm excited to swap ideas about this interesting synchronization utility. Before we begin, listeners should be familiar with basic concurrency concepts and the java.util.concurrent package, which provides high-level concurrency utilities in Java.
Great point, Victor. Now, let's start with a quiz question for our listeners. Here's a scenario. Imagine two chefs in a kitchen, each preparing half of a dish. They need to exchange their prepared ingredients at a specific point to complete the meal. Which Java concurrency utility would best represent this synchronized exchange?
That's an intriguing question, Sheila. It really makes you think about how we can model real-world synchronization scenarios in code. I like how it focuses on the exchange of items between two parties. Our listeners will need to consider which utility allows for this kind of two-way synchronized swap. Let's keep this question in mind as we explore the topic.
Excellent, Victor. Now, can you give us a basic definition of the exchanger class? What's its primary purpose in the world of concurrent programming?
Certainly, Sheila. The exchanger is a synchronization point at which two threads can pair up and swap objects. It's part of the java.util concurrent package and is designed for situations where two threads need to exchange data.
That's interesting. So it's like a meeting point for threads. Can you elaborate on how it actually works?
Of course. When a thread calls the exchange method on an exchanger, it will wait until another thread also calls exchange. Once two threads have called exchange, they both receive the object that was passed by the other thread. It's a bit like a synchronized handshake between two threads.
I see. So if I understand correctly, it's almost like a rendezvous point for threads. Can you think of any real-world analogies that might help our listeners visualize this concept?
That's a great way to think about it, Sheila. A perfect analogy would be a baton exchange in a relay race. Two runners meet at a specific point on the track to hand off the baton. In our case, the runners are threads, and the baton is the data being exchanged.
That's a helpful analogy, Victor. Now, I'm curious about the use cases for exchanger. When would a developer typically reach for this class in their toolkit?
Exchangers are particularly useful in pipeline designs, where one thread is producing data buffers and another thread is consuming them. Instead of simply passing data from producer to consumer, you can use an exchanger to simultaneously supply consumed buffers back to the producer for reuse. This can lead to more efficient memory usage.
That makes sense. Are there any limitations or potential pitfalls we should be aware of when using exchanger?
Absolutely, Sheila. One key thing to remember is that exchanger is designed for use between two threads. If you have an odd number of threads trying to use the same exchanger, one will always be left waiting. Also, if one thread calls exchange but no other thread ever does, it could lead to indefinite waiting.
Those are important points to keep in mind. How can developers handle these potential issues?
Good question. For the indefinite waiting issue, the exchanger class provides an overloaded exchange method that accepts a timeout. This allows a thread to abandon the exchange attempt if it's been waiting too long. As for ensuring paired usage, that's largely a design consideration. Developers need to structure their code to ensure that exchanges are always used in pairs.
Thank you, Victor. Now let's dive a bit deeper. Can you explain how exchanger handles null values? Are there any special considerations?
Certainly, Sheila. Exchanger can indeed handle null values, which is quite useful. A thread can pass null to the exchange method, and it will still work correctly. However, it's important to note that if a thread receives null from an exchange, it can't distinguish whether the other thread explicitly passed null or if an interruption occurred during the exchange.
That's an interesting edge case to be aware of. Speaking of which, are there any common misconceptions or mistakes developers make when using exchanger?
One common mistake is assuming that exchanger guarantees fairness. In reality, there's no guarantee about which thread will be unblocked first, if multiple threads are waiting to exchange. Another pitfall is not considering the memory consistency effects of exchange. The values exchanged between threads are safe, but developers need to be careful about the visibility of other shared data accessed before or after the exchange.
Those are valuable insights, Victor. As we start to wrap up, could you share any best practices or tips for using Exchanger effectively?
Absolutely, Sheila. First, always consider using the timed version of Exchange to avoid indefinite waiting. Second, ensure that your application design guarantees paired usage of exchangers. Third, be mindful of the objects you're exchanging. Large objects or deep copies can impact performance. Finally, remember that Exchanger is a powerful but specialized tool. For many scenarios, other concurrency utilities might be more appropriate.
Thank you, Victor. Those are excellent tips. Now let's circle back to our quiz question. Can you reveal the answer?
Of course, the Java concurrency utility that best represents the synchronized exchange between two chefs would indeed be the Exchanger class. It perfectly models the scenario where two parties, our chefs, need to meet at a specific point, the Exchanger, to swap their prepared ingredients, the exchanged objects.
Perfect. To summarize today's episode, we've learned about the Exchanger class, a synchronization point where two threads can swap objects. We've covered its basic usage, potential pitfalls, and best practices. Remember, Exchanger is particularly useful in producer-consumer scenarios and pipeline designs, but it's crucial to ensure paired usage and consider timeouts to avoid waiting issues.
Excellent summary, Sheila. In our next episode, we'll be discussing Thread Local, another fascinating tool in Java's concurrency toolkit. Listeners, you won't want to miss it.
That's right, Victor. And to our wonderful listeners, if you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of Java's internals. Until next time, happy coding.